Take that as good. I feel like people cleared the front lawn very early last night for the fact that that study hall didn't start till 8:30.
I think they like turned off the lights.
Oh, I see. So they that's good. So they turned the lights off still at 7:45.
Yeah, something like that. I'm not sure.
That's good to know. I can ask about that. Great. We'll wait another minute or two. Looks like we have at least one guest. Thanks, Amanda, for joining us.
Yeah, hi. I'm actually Jackson. I'm
Oh, there we go.
Computer. I can't find out how to rename.
No worries, Jackson. It is. So thanks for joining us. Okay, we'll jump in. We'll see if anybody else jumps in. And we'll let them, they'll just get to jump in with us. So today we're sort of switching back to what we were doing. Oh, and just so you guys know, even if we don't have more people join us, this video ultimately will still get sent to admissions in case they want to show other people. So we're still in the hot seat, even if we only have one person joining us. So it's good we have at least one, but we'll do things like that. So we're switching back to sort of what we were doing with virtual. So Mr. Daly has made a lab sort of looking at the silver content of a dime. This is really more related to what we're heading into with talking a little bit about different types of bonding and alloys and stuff like that. So don't stress too much. It's different than the solutions and the molarity stuff we've been learning about, the stuff that's on your test for next Thursday. So this is sort of a little bit of a different exploration that works really well for the virtual stuff, but will be sort of stuff that's coming for the future. So all of it is well within your control and grasp of knowledge. So we'll sort of do some breakout room stuff and we'll go back and forth like we did, if you can think back to before we were back in person, which already seems like a long time ago. And then this is sort of a one-off little chunk of stuff though. So hopefully everybody is able to have a copy of the lab in front of them. And Jackson, you'll be able to see the lab. There'll be some times when we go into breakout rooms and the breakout rooms have the labs in there. So I'll share it with you there. So you'll get to see that as well. But we'll jump in. Oh, hi. Great to see you, Jackson. We'll jump in. And so we'll start watching the video of Mr. Daly working on this lab. We'll break for a second to sort of calculate the first thing, and then we'll continue with some secondary calculations further on down the line. Who knew that labs used to be made, or dimes used to be made of silver? Anybody? Excellent. Some hands. Yeah, so it's very similar to the penny. The composition changed, right? It got expensive to make dimes out of silver. And so the composition has changed. Dimes no longer have any silver in them. They're copper and nickel. Before that, they did have a silver in them, but they weren't completely silver. They're a silver copper alloy. And so what we're going to try to figure out is how much silver was in the dime. Anybody have any initial guesses? None? Okay, no worries. So I'm going to share. We'll start watching this video. Mr. Daly will sort of describe what he's doing, and then we'll come back. If you have any questions, let me know. Great. Hopefully everybody can see that. I will make this as small as possible so it's not in the way.
Okay, you're looking at a little slice of a silver dime. And so in this lab, what we do is we react the silver copper alloy with nitric acid, and then we precipitate the silver ions using chloride, and then we will rinse and dry that precipitate, weigh it, and ultimately determine the percent of silver in a silver dime. So it's a pretty complex lab. Hopefully you guys will enjoy it. Thanks. Okay, we'll start out by weighing this little slice of silver dime. And so I've got the balance already tiered. Put that in there, and it looks like 0.372 grams. And so we'll write that down and take it over to the hood and react the silver dime. Thanks. Okay, I've got the piece of dime sitting in a 100 milliliter beaker, and I've actually got a watch glass sitting on top, so in case there's any spattering, that'll prevent that from escaping. And right here I've got 10 milliliters of 6 molar nitric acid. The reason this is sitting...
So we now know what that means. What is the 6 molar in reference to?
Well, it's the moles over liters
Yeah.
in the solution.
Perfect. So it's the concentration. So now you know when we're using like a 6 molar amount of an acid, that's a concentration of how strong the acid is. So if you all wanted, if I asked you to make 6 molar of the nitric acid, you could go do that. And it depends on how much you would need. You'd go get the volumetric flask. You'd measure out what you needed. And then remember, you'd add enough water to be able to fill that up. So excellent. So you all could go make that solution if you had to. And now you know what that's in reference to. It's not just some unknown thing of what 6 molar means. Perfect.
On a hot plate is if we warm it up a little bit, the reaction goes much faster. So we're going to react this copper silver alloy with nitric acid. I'll take a few shots during the reaction because you'll see a couple of cool things. Okay, thanks. Okay, so now we need to weigh.
So Mr. Daly put the dime into the beaker and then he mixed it. Then he put the nitric acid on top of it. The solution turned sort of that bluish green. Anybody know what's causing the bluish green color? It's the same sort of thing that's happening to one of America's most famous monuments.
Oh, is it oxidizing?
Yeah, well, and so what is it? What is the what's the underlying chemical that's causing it to turn that color?
Iron.
It's not iron. Good thought though.
Copper, right?
Copper, yeah, copper. So same thing that's happening on the Statue of Liberty. So that's why the Statue of Liberty has that greenish color in it. Same thing's true there. So we can talk here in a second about sort of if we know that that solution's got that greenish blue color, then we can sort of understand where the copper ions are versus where the silver ions are, because we know it's a mixture of copper and silver. So what's going to happen here, Mr. Daly is going to measure out some sodium chloride, and then we're going to calculate how much he needed, because he's going to talk about needing more than what we need. So we'll talk about what that means, and then we'll calculate it using some stoichiometry, and I'll send you into breakout rooms here in a second.
The sodium chloride to precipitate those silver ions from solution. We've calculated how much sodium chloride we need, assuming that the alloy was 100% silver, and then we actually double that amount, so we are sure that the chloride is going to be in excess. So let me weigh that out real fast here.
So while he is weighing that out, we're going to go calculate it ourselves. So let me quickly share my screen and we'll go over what we're doing. So this first part of the reaction was Mr. Daly mixing the silver with the nitric acid. We did not give you that equation. It's sort of a complicated equation, so don't worry about that. This is sort of the ultimate piece of that is what we're looking at, which is that the silver and copper ions, which originally were in an alloy together. Does anybody know what an alloy is? We've talked about it a little bit, but not a ton. That's something that's sort of coming for the future.
Two solids.
Wait, say it again, MJ. You broke up a little bit there. We lost MJ.
Oh,
Anybody else?
it's like it's dirt.
Say it again.
It's a mixture between two solids.
It is a mixture. It's more specific than just two solids. It's a mixture between at least two
Metallic.
metal things. Perfect. Excellent. Yeah.
Yeah.
It's a mixture between two metals. When we discuss it later, you'll learn that they don't actually, they're not bonded together, but because of their properties, they're able to mix together like that and come up with sort of a different, something with different metallic properties, given the 2 or 3 or 4, however many metals are part of it. But you could separate them if you melt it back down. And that's exactly what we're doing here. We're not melting it. We're mixing it with the nitric acid, but we can re-separate those and get those ions back into solutions. We've got silver ions and copper ions, which is what is existing in that nitric acid thing. Now we want to get the silver ions isolated so we can mix them with NaCl. What's NaCl again?
Table salt.
Table salt. Excellent. So exactly what you have sort of sitting at your table to make your food taste better. And so we'll mix it with the NaCl, and that will get the silver out of solution. So we'll see that it'll form a precipitate. And we'll talk a little bit about what that means. So you have all of the data that you need right here. I'll share the Google Jamboards in a minute. And then the first thing we're going to do here is if we assume the alloy is 100% silver, so all Ag, all silver, how much NaCl do we need? Because we don't want NaCl to be our limiting reactant. So that's why Mr. Daly's talking about making it double what that is. So I'm going to send you into breakout rooms. For those of you that are joining us, breakout rooms and sort of working in small groups is a huge part of what we do. So when we're virtual, we try to replicate that by using the Google Jamboards. So I will share the Google Jamboards with you. We'll go into 1 and 2 like normal. And then what I'm also going to do is I'm going to keep, this is going to be a little different. I'm going to send one group to a breakout room and one group is going to stay in the main room, just so that, again, when we share the recording, otherwise when you go into breakout rooms, the recording just sort of shows nothingness. So that way one group's sort of will be recorded in the breakout room because they'll just be part of the main room. So the pressure will be on if you're in that one. So let me go there. For those of you joining us, if you go to that Google Drive link, and then if you're, let's say, if you go into a breakout room, you're going to go to breakout room 1. If you stay in the main room, you're going to use the breakout room 2 Jamboard. I am going to make sure that we have a good split of people. So let's see here. If you guys give me 1 second. Okay, any questions about what you're going to be doing? I'll jump into both of them to help you. But right now, we're just doing the first part of this, which is assuming the alloy is 100% silver. How much NaCl do we need? So how are you going to do that process?
Stoichiometry.
Stoichiometry. Excellent. So you're going to have to think way back in the day. We haven't done stoichiometry for a little while. We were doing it at the beginning of solutions. So think back, and we will come back in a moment. So I'll send you out to your rooms, and then I'll bring you back momentarily. Actually, sorry. The rooms are a little wonky. I'm gonna. Okay, great. Hopefully this works. Again, and then if you're unassigned, you're just gonna stay in the main room and pretend like you're in a breakout room, and that'll be breakout room 2. Awesome. So I'll stop sharing if you guys want to be able to share sort of what you're doing. That would be really helpful, just because people won't be able to see your Jamboard. So if one person could share sort of your Jamboard, that would be fantastic. You guys are in the hotspot. I trust you to do some great work.
What number are we for the Jamboards?
Yeah, go to group 2. You'll be group 2 just because you're not. Yeah. And I'm going to go check in on the other group and then I'll be back. But yeah, group 2, if someone could share the Jamboard so that, again, if people watch us in the future, they can see what you're physically doing. That'd be super helpful. Awesome. Thanks, guys.
I can share if you want.
Recall stage. Oh yeah.
All right, can you guys see?
Yeah.
Okay. All right. So, assuming the alloy was 100% silver, 0.372 grams of silver, how much NaCl did we need?
That's a smart.
Should we turn, like turn it into moles? I'm guessing. Like,
I think we should do. I think we should do grams because I'm assuming that. Yeah, I think it's going to be grams because everything else is in grams. I think it should be grams.
Yeah, but like go like mole ratio into NaCl. And like, wait, hold up.
No, because we don't have the equation. Or
Oh
maybe,
yeah, okay, never mind.
oh, we do have an equation, but I don't think it.
Excellent. Looks like a great start.
Then we need to change that to moles. That's the word.
Mhm.
And silver is 107.9 grams per mole.
Mhm. And then we need to do. That. How much is NaCl in grams? I don't know, my period.
Oh, here I got it. Na is 22.999 and Cl is 34.45. So it's
30 CL is 35.45.
oh yeah, you're right. Sorry.
Cool. And that would just be.
Okay, so I'm just multiplying.
Wait, don't we have to cancel out the moles of AG?
Oh yeah, shoot! I flipped. No, wait.
No, because if you go to moles,
Yeah,
then if you go to moles of silver, then you can go to grams of NaCl.
Perfect. Yeah, you guys are just missing the one important step in between there.
Oh, it's the ratio, right?
Yep, the mole
Yeah.
ratio.
But
Perfect.
it's the mole ratio is just one.
What-
And the mole ratio is
what-
1. That Romy was just asking that exact same question. And it's one of those things where it's good practice to have it because you're showing sort of how you're going from one thing to another. But mathematically, it's not going to make a difference for you in this situation.
What did Brandon just say? Thank you, Mr. Ray. They never listen. They
1/1.
never listen. But still, you have to show it cancels out. They never listen.
All right.
You haven't gotten your Nobel Peace Prize yet, Brandon. Calm down.
I'm 17. It's coming. It's coming. Give me time. Yeah, I got a lot of life to live.
That's true. You do have a lot. Now that remember, he's a chemist now that he did a titration. So he's come a long way. He's already done a lot this week.
Mr. Ray gets it.
All right, let me get a calculator.
I'm just going in. I'm doing it.
Okay.
I got it.
Great. I will bring them back, the other group back here in 1 second. I'll check on them. And then it looks like you guys are almost there. They were almost there as well.
No.
Excellent. Great work. Good work on the sig figs. Before I bring the other group back, we have one guest that's joining us. Do you want to quickly introduce yourself? I'm going to go under the name that perhaps Jacqueline is your mom. But so I just want to get your real name.
Oh yeah, I'm Joshua. Yeah.
Joshua, great. Hopefully you enjoyed. This is a A+ group that you got to see in action. But
We're doing sort of this stuff. We'll be in 8th grade science, so
awesome.
I had a relative understanding.
That's great. That's really good. Well, you should have jumped in and you could have told them off about missing that mole ratio. Perfect. Okay, let me bring the other group back. We'll review. You guys, everybody did great on that. Excellent. Welcome back. Each group did really great job on that. So we'll just run through this quickly. You guys remembered your stoichiometry even better than I anticipated. So how do I want to start this off?
Question mark grams of NaCl.
Great. Question mark grams of NaCl, because I'm trying to figure out how much we're going to need in this situation. You guys know NaCl is sort of a powder, a crystal. And so we're going to measure it we're going to have to get the mass of it. And so therefore we're going to need it in grams. So grams NaCl, and I'm starting with 0.372 grams of silver. And that is going to then, what do I have to go to first?
Moles of silver.
Moles of silver. Excellent. And what was how do you go from grams to moles again?
You use the periodic table, so you
Perfect.
put 107.9.
Excellent. You find silver, use the molar mass, so 107.9. Grams of silver goes to 1 mole. And then again, Romy asked a great question and both groups sort of had a discussion here. What's the next step?
You have to mole ratio, but it's just 1/1.
Great. So you do still, even though I know it's annoying, you do still want to write the mole ratio, even though it's 1:1, just because that's helping you realize you're going from the silver to the NaCl. So this is an important step. Remember, we used to put the box around it just to sort of denote how important it was, because the only way to go from one substance to another is to use that mole ratio in the balanced chemical equation. So it does play a really important role for us. And then finally, I need to go from moles of NaCl to grams of NaCl. And what was the molar mass? Does anybody remember?
58.44.
58.44 grams of NaCl. And we found that again from the periodic table. We can then do all of our math there. And what did people get?
0.201.
0.201 grams NaCl. Excellent. And so if Mr. Daly, if we use just 201 grams, what would that mean?
That the NaCl will run out at the same time as
Yeah, that the
sulfur.
Na, and so then why does Mr. Daly want to double it in our lab?
To make sure in case there's a calculation
Perfect.
error.
So that's like we're making sure it's in excess. Exactly. So we don't have to worry about it being a limiting reactant or anything because we're making sure the NaCl is in excess. Because if we ran out of NaCl, thinking about this sort of equation right here, if NaCl was the limiting reactant, what would that mean for our end result? If that's what gets the silver to sort of come out of the solution.
Not all of it would come out.
Exactly. Not all the silver would come out. And so our final answer would be too low because we wouldn't have gotten all the silver out of solution. So that's why it's really important that we put in way more NaCl than we actually need. That way we know we've gotten all the silver covered. We already know we're probably in some excess because this is also assuming 100% silver. And we know it's an alloy, so we know it's not going to be 100% silver. But we really want to do sort of our due diligence to make sure we're doing that. So let me share this screen again, and we'll be back to Mr. Daly continuing with the lab. We'll really go through the rest of the lab here, and then we'll do some more calculations once we get on the other side. Right there, he's just measuring out the NaCl very carefully, making sure he gets double the amount.
There we go. That's more than twice as much. And I'm going to add that to a little beaker. And I'm going to add 25 milliliters of water. And I've got a glass stirring rod here. So I'm just going to stir that till it is dissolved, and then it will be ready to use. Thanks. Okay, the reaction's over. Hopefully you saw the color of the solution was blue. That's actually the copper ions in solution. You don't see the silver ions in solution. And then you saw the brown gas. That brown gas is the same gas.
If you look really closely, you can still see a little bit of sort of the brownish right up there. Mr. Daly's going to explain what that brown gas is right now.
You might see in Hong Kong or Los Angeles when I was a kid. It's actually an equilibrium between nitrogen dioxide and dinitrogen tetroxide. So it's cool. It's also poisonous. So that's why we do it in the hood. So the next step, what I need to do is I need to rinse the watch glass into the beaker, and then I'm going to add the sodium chloride solution we made. So I'll show you a close-up of me adding the sodium chloride solution. So I'm just going to rinse this guy in here. Go. And then I'll come back and show a close-up of adding the sodium chloride solution. Okay, we need to weigh a piece of filter paper. And this filter paper weighs 0.934 grams. So we'll take it over to the hood and get started. Okay, the way you use filter paper is you fold it in half. And then you fold it in half again. And then you open it up. So, well, you open it up so it makes a little cone. And you put the cone inside a funnel. And if you put a little water in there, that will cause it to seat, to stick to the funnel. So that should be ready to go. Okay, we've let the solution heat for about 15 minutes. That causes it to peptize, to make bigger chunks. And so now we're getting ready to filter. So this is actually a multi-step process. And the most important thing here is to make sure that we get all of the precipitant into this flask. So this is actually a filter flask setup. If I turn it on, it's gonna be really loud. So I'll show you some video of when it's running, but it's quite loud. So literally at this point then, we take this and we start to pour it through the filter. We've got to get all of that precipitant into the filter. So this takes a little bit of work. Okay, we've reached the last part. So we're just going to take our filter paper out. It's got the silver chloride precipitant in there. And we're going to take it over here to an oven and stick it inside there. And we're going to let that dry. So we just have to wait for that to dry overnight. Okay, it's the next day. Just took this out of the oven. I'll stop right here and show you a quick picture of what it looks like with the silver chloride precipitant. Okay, now let's weigh it. So got the balance tare here. I'm going to put the beaker that the filter paper was sitting in on here and tare it. Put the paper in there. 1.377 grams. So we'll use that mass of silver chloride precipitant to try to figure out the mass of silver, which then will take us back to the mass of silver in that original silver copper alloy. Okay, thanks. Okay, that wraps it up. It's a pretty cool lab. Got to watch a alloy of coinage metals react with nitric acid to put the metals in solution. Got to see a selective precipitation of the silver ions, leaving the copper ions or copper 2 ions in solution. Got to see how to take a precipitant, filter it, rinse it with a dilute strong acid rinse. Got to see vacuum filtration, got to use the oven. And so lots of cool things, lots of lab errors, lots of things that can go wrong. So anyway, hopefully you guys enjoyed that lab. Thanks.
So that is sort of the lab in its entirety. And so what we're going to do is now I'm going to set you loose on a few more calculations. You'll do these calculations, we'll review them, and then we'll come back and we will discuss sort of the best parts of the problem, which are what could have gone wrong. Exactly what Mr. Daly said, right? Think about the number of steps that we had to do in that whole lab. You can imagine there's a lot of places that you could have gone astray and something could have happened. And we need to think about how those could potentially have affected our end outcome. So we'll get to these post-lab questions at the end. But I'll send you back to breakout rooms. You need to determine the mass of the silver chloride. How are you going to do that? Any initial ideas? Where is the silver chloride sort of at the end?
Oh, you just subtract it from, because you only have the mass of the filter paper and the.
Perfect. So that's going to, yep, it's on the filter paper. So you're going to have to use that stuff. And then how are you going to figure out how many grams of silver are in the silver chloride precipitate? What are you going to have to use again?
Oh, do you have to subtract it again?
It's not going to be a subtraction this time. What do we have to do if we're going to go? We want to know how much of one piece it is in a whole. What's our process for doing that? Going from silver chloride just to silver.
Oh, you have to use the mole
ratio, exactly. So we're going to do some more stoichiometry, and then we're going to finish by finding the mass percent of the silver alloy. And I'll leave you to sort of think about how to do that because I think that you guys can figure that out pretty easily. So I'm going to shoot you back into the breakout rooms. I'll jump back and forth. We're going to take probably maybe 5-ish minutes to get through these. They're all pretty short questions. And then we'll come back for the post-lab fun. If you finish those, you can start thinking about the post-lab questions, which are on the next page of the Google Jam once you finish that. So with that, I will open the rooms. Excellent. And I'll jump back and forth if you have any questions.
All right, should I share my screen again?
Yeah.
Okay.
Joshua, again, if you think they're going astray, don't be afraid to call them out. If you come, they might be your seniors next year, but that means you can sort of power move them now by telling them how by showing them your chemistry knowledge.
It's gonna be
It's 1.377.
I got 0.443 for the massive EGCL.
Yeah, same.
You got what again?
0.443.
Why did I put? How many grams of silver?
So what are we using here? It's
Isn't it the mole ratio?
Yeah.
it's so it equals the 0.443.
Yeah. Well, you have to go from that to moles and then the mole ratio and then the.
Yeah. So wait, give me a second. I'll look. What is the
AG is 107.9
Mhm.
what's the other one?
and CL is 35.45.
One 43.35.
And then what was AG again? It was like 107.
107.9.
Just gonna equal. So I got 0.333.
So how do we figure out the mass percentage?
Of silver in the alloy. I guess it would be actual over theoretical
Oh, right.
times 100. So
That was great thinking. Remember though, you don't have a theoretical here because the theoretical we calculated was NaCl. So think about what we want to know how much silver is in what.
Would you do the AG, like the mass of AgCl, or like the mass of AgCl over the mass of Ag?
well, we
So
have.
we want to know how much silver. What do we want to know how much silver is in what?
in the silver alloy, but we have the mass of the silver alloy on the page before.
Excellent. So yeah, we want to know how much of it was in the dime that we started with. That little chunk of dime, actually, I really should say.
0.372. Yeah, and that tells 100.
Awesome. Great work there. I'm going to go check on the other room and then we'll bring everybody back. We'll review those and then we'll talk about the meaty questions of what could have gone wrong.
I don't know why it's breaking up. That's fine.
Excited for game day, Sage and Rock?
Oh, yeah.
Of course, of course.
Who are y'all playing?
First State Military Academy.
Awesome. You guys are all done?
Yeah.
Excellent. Let me bring everybody back. What'd you get for your final percent?
89.5.
Great. Think about your rounding there, but excellent. Actually, it looks like, I think you were right, MJ. I was wrong. Your rounding was good. That was me. I'll take the blame for that one.
I accept your apology.
Okay, it looks like everybody did some really great thinking there. So I'll just quickly run through the calculations we did, just in case you have questions. Feel free to ask, and then we'll get to the final part. So determine the mass of the silver chloride. What we needed to do is just take the mass of it really nicely dried out at the end, minus the filter paper. And the only thing that was left in that was the silver chloride. Then we needed to figure out how many grams of silver chloride were in the precipitate. Remember, so the precipitate is what we've just have been talking about, solution chemistry. And so the precipitate is what is not in solution. So the copper ions were in solution still, but now the silver and the silver chloride ions in this case were not. So the chlorine sort of comes in, bonds with the silver and pulls it out of it. So you get that nice sort of cloudiness that ultimately then turns into a solid as it sort of settles and heats. So in that situation, just some more stoichiometry going from silver chloride to just silver, you should have got about 0.33 grams of silver. And then finally, the mass percent is how much silver we had in the beginning, or sorry, how much silver we calculated over the amount of alloy we had in the beginning times 100. And so we got that it was about 89.5%, somewhere in that range. The true value is somewhere at about 90%. So we were really, really good. So we can feel pretty confident in our results, but we still, again, sort of the most challenging questions are down here when we think about if something did go wrong, how would it have affected us? So the first question asked is, we wanted the mass of just silver, but what we really determined was the silver ion, the silver plus. Is it reasonable that the mass of the ion is the same or similar enough to just the mass of silver in its neutral form? What do we think?
Yeah, I mean, because the difference of one electron isn't too much.
Perfect. So MJ is remembering that the plus means that it has one less electron. Remember, if it was sometimes people jump and they see the plus and they think, oh, maybe it has one more proton. But if it had one more proton, what would that mean?
It's a different element.
It's a different element because remember, protons are fine elements. If you remember way back to the slamming of the table and the thinking of those days. And so one difference in electron, how small is an electron?
Really small.
Super, super small. So yes, this is really, really reasonable because we really, even when we're talking about, right, a huge number of particles, one electron is still not going to make a meaningful difference for whether or not we got a good solution. So yes, we can feel pretty confident about that. For the next one, if the silver chloride precipitate was not completely dried, the percentage of silver in the alloy would be what? We didn't completely dry it out. So we can see here sort of a picture of it. If there was still some water mixed in with it, so this example right here, how do you think that would have affected our end result?
Would it be too low?
Too low. Why do you think too low?
Because there would be more non-silver substance in the thing. So lower.
Perfect. Excellent. Yes. So it would be too low. Awesome, Jackson. That was great. Because remember, if we think back up here, essentially this would have weighed more because water would have been on it, meaning that this would have gone up, this would have gone up, this would have gone up. So ultimately, when we think back to calculating our percent, we would have thought there was more silver. Sorry. So we would have thought there was more silver. I think you have the right idea there, Jackson. Just the flip. So it's actually, we would think it was too high because of the weight, but you had done the right thinking there. Sorry about that. But ultimately it'll be too high because we think we have too much silver in the solution. I think you had the exact right logical thinking there, Jackson. That's why these problems are so tricky though. So if you neglected to rinse the silver chloride precipitate, so remember after it was all in there, Mr. Daly went in and gave it a second rinse. What do you think that might have caused? That example, we're thinking sort of more of this one, where that color represents, that greenish color represents the silver chloride. Or sorry, that green color, remember, represents the copper, and this sort of hazy bit is the silver chloride. What could have happened this time?
Well, then it probably would have been too high if there was leftover bits of the
and why do you think too high again?
Because it would affect the weight, well, the part thinking of the weight of the silver. So then when we did the final equation, it wouldn't work out.
Perfect. Same exact thing. In this situation now, this would still be a little bit higher because there still would have been some copper ions on there, meaning ultimately, again, this would be too high, this would be too high, this would be too high. So then when we get down to our final thing, again, the amount of silver we think we have is a little too high, and that means we have too much. There's a chance if it was well mixed and rinsed and everything, it could be unaffected if, you know, all the copper, but it's unlikely. You want to do that second rinse to really make sure you're getting all the copper ions and anything else in that solution off of it. So you just have the silver left. And then this last one for this piece is if you lost pieces of the silver chloride precipitate, then the percentage of copper, I don't know why. Oh, okay. So tricky here. So if you lost bits of the silver chloride, let's stick with silver here first. Then we could think about copper. The percentage of copper in the alloy would be what? Or sorry, silver. We're going to keep this as silver for now. So if we lost bits of the silver chloride, what would happen to the amount of silver that we calculated?
Wouldn't it go down?
Why would it go down?
because you're losing silver.
Perfect, because we would have less of it, right? Think about when Mr. Daly was carefully scraping it out. You can see at one point some of it was sticking to the spatula. If he were to then get rid of that spatula, right, and not squirt it off and lost some silver there, then ultimately the amount of silver we calculated would go down, and therefore the percent we calculated would go down. If we think back to this as it was written, the percentage of copper in the alloy would then be what? We would think the percent of copper. If the silver is too low, the copper is too
High.
high. Exactly. So we would think that the copper was overrepresented in it. But I think this is one of those ones where it's probably easier to think about it from the silver standpoint and then go back and think about how that would affect the copper. The final one here is something we're heading into. So you might not have the answer to this, but maybe you learn enough, or maybe Jackson and Joshua have picked up enough in some of what they've done. In this case, we used silver or sodium chloride. Is there another ionic compound that you think we could have used? And remember, we have to use chlorine because the chlorine is what helps precipitate out that. So is there another ionic thing, which we haven't really totally talked about what ionic means yet, but is there something else that you might think of? I'll show you the periodic table that we could have used.
Could we use HCl?
That's a really good thought. HCl is an ionic, even though it has the chlorine in there and the hydrogens over here, which in general, we'll learn the ionic things are usually between, well, are always between sort of the metals over here and the non-metals over here. But that one will not work for us. But that is a really good thought.
Could you use calcium chloride?
Excellent. Calcium chloride would be a perfect example of one we could use. So that's an ionic compound, very common in the ocean. It's sort of what makes sandstone and all of those things, and some of those sort of bits is calcium chloride, or not sandstone, but it makes up shells and stuff like that is what I'm getting at. So really important thing. So we could have used calcium chloride. We could have used magnesium chloride. We could have used sodium chloride. So any of sort of these things, you're starting to see what some of these ionic solutions potentially could have been. So awesome. Thank you all so much for your time and great work today. There's a homework for some titration stuff available on Canvas. We'll talk about that next class. And then on Tuesday, you're going to actually do a real titration. So not just a drop titration, you're going to do sort of the one with the burette and all of those pieces. So get excited for that. Start fine tuning those motor skills because it requires just the right touch. And Jackson and Joshua, thanks so much for joining us today. If you guys want to hang out, if you have any questions or you want to talk about science at St. Andrews or anything, I graduated from St. Andrews sort of a decade ago, so I can also answer any of those questions. Feel free. If not, have an awesome day. And thanks so much for joining us.
Thank you.
Awesome. Have a great day.
Thank you.
I have to go, but thank you for the class.
Yeah, no worries. Thanks so much for joining us. And thanks for actually jumping in and participating. That was awesome. You both are great. I hope you're seriously thinking about coming because it seems like both of you would be great additions to our program. So I hope you'll come.
Thank you.
Awesome. Thanks, guys.
Bye.
Thanks, Kai.